All right, we'll get started. My name is David. I head up marketing here at Fairwinds. First off, thank you all for joining the webinar and being flexible around the workshop. So today we have Kim and Mary. They're both SREs at Fairwinds. Kim is one of our lead educators here, and Mary will be here to answer any questions that you might have. If you do have any questions, you can use the Q&A feature or chat feature at the bottom of the Zoom menu. So first of all, we'll have an introduction around Kubernetes and GKE, and then we'll break out for the hands-on portion of the workshop. And if you'd like to receive the slide deck and recording of this webinar, we have a brief survey at the end where you can provide your contact information, and we'll send that right away. And with that, I'll hand it off to Kim. Thanks, everyone.
Great. Thanks, David. Welcome, everybody. This is Getting Started with Kubernetes on the Google Kubernetes Engine. And after going through some concepts and getting ourselves set up on Google Cloud Platform, you'll be building, deploying, and working with your first Kubernetes cluster in GKE. So first thing that we want to do before we get started is make sure that everybody has an account on Google Cloud. We'll be using this to create our clusters during the workshop. As you signed up and you RSVP'd, you should have $300 of free credit when you sign in, which will cover way more than the cost of the actual cluster and workloads that we deploy in the cluster. There are lots of other things aside from Kubernetes on Google Cloud Platform, so you can also use the credits to cover that. So before I begin the presentation, I just want to make sure that everybody has an account or is in the process of signing up. So I'm going to stop sharing. And yeah, if you can go to Google or cloud.google.com. And if you're having issues, you can either drop something in the Q&A channel or in the chat channel. So I'll wait a minute or two before we hop into the conceptual part of Kubernetes. So Kyle says he had an account previously. Is there a way to apply the credits to an existing account? I don't know the answer to that, but could David or Scott or Anthony look into that? And the cluster that we build today and the workloads we run, I've done a couple times the last few days. It's been about $3. So as long as you delete the cluster at the end of the workshop, it shouldn't cost much. All right, David says you have to sign up for an account using a new email address to get the credits applied. So if you just wanted to have like a GKE101@gmail.com, that would probably work. Nice. David says, if you'd rather not create a new email address, you can talk with him and he'll contact a Google rep and try and get you the credits after the workshop. All right, so I'm assuming everybody has access to Google Cloud Platform. You will want to go to cloud.google.com, and it's okay if you are working through that as we go through the introduction. So let me share the slide deck again. All right, so let's move on. So here's our agenda for the day. First, Mary and I will be introducing ourselves. Then I'll be covering what Kubernetes is, what problems Kubernetes solves, as well as covering high-level concepts. Third, we'll set up a demo Kubernetes cluster using the Google Kubernetes Engine. Fourth, we'll deploy a simple web application to this cluster. Then we'll go through some normal cluster operations and things that we do in this demo deployment running on the cluster. Next, we'll tell you about the kinds of services and software that we offer here at Fairwinds. And then finally, with the time remaining, we'll do a question and answer session for any questions that you have. So there is the Q&A feature in Zoom. Mary's going to be monitoring that through the presentation. And when I get through each of these big parts of the agenda, I'll pause to look at that. So feel free to ask questions there. It may take us a few minutes to answer. So let's start with introductions. I'll start with myself. Hi, my name is Kim Schlesinger. I live in Broomfield, Colorado, and I am a site reliability engineer at Fairwinds. I've been with the company for a year and 3 months, and at this job was the first time I ever used Kubernetes professionally. Prior to Fairwinds, I was a web developer using JavaScript and an educator. I taught elementary school. I also did professional development sessions for teachers, and I worked at a software development boot camp for a long time. So I have deep education experience, but I'm also a technologist. And right now my professional interests include monitoring and Linux. So I'm going to pass it on to Mary to introduce herself.
Hi everyone, welcome. I'm also an SRE at Fairwinds, and I'm in through their apprentice program. I just recently graduated from a boot camp here in Denver where I live called Turing. I didn't have a background in technology before that. I worked on a boat, I bartended, a lot of that stuff. So I did a huge switch of career, and I'm super excited because this is everything I wanted to learn. Same as Kim, this is the first time I've used Kubernetes professionally, and I really like it. What I'm really into right now is learning Golang, using Vim, and I'm pretty interested in Docker. So I've been exploring that a lot. Feel free to hit me up with any questions you have during this. Back to you, Kim.
Thanks, Mary. All right. So who are we? We work at a company called Fairwinds, and Fairwinds is a consulting company that specializes in helping other companies build and maintain great cloud infrastructure using Kubernetes and DevOps best practices. Basically, the proposition is that we focus on building and managing your Kubernetes infrastructure so that you and your developers can focus on building your products and growing your business. So we are experts at managing Kubernetes clusters. So with all the introductions out of the way, let's get into Kubernetes 101. This presentation assumes that you have working knowledge of Docker and what containers are, but it's geared to be an introduction to Kubernetes for people who are brand new to that platform. For those of you with significant Kubernetes experience and looking for advanced information, you're welcome to hang out, but a lot of this information will be old hat for you. And we do offer advanced Kubernetes workshops. You can contact us and we'll let you know when our next one is. So with that all said and expectations set, let's get started. So Kubernetes 101. So what is Kubernetes? Kubernetes is a powerful open source system for automating deployments, scaling, and management of containerized workloads. Kubernetes acts as a platform as a service for developers to deploy containerized workloads. You can then use the Kubernetes API to manage applications and resources through the command line. So where did the name Kubernetes come from? The origin of the name is from the Greek word Kubernetes, and that word translates to helmsman or captain. So you should think of Kubernetes as the captain that keeps track of all your applications. It knows where to route traffic, where each container is, how many resources each container is using, when to scale up and when to scale down. It's really in charge of your workloads. Here's how I like to picture Kubernetes. So this is a visual metaphor. Got a picture of a container ship on the ocean. And so the actual container ship is like Google Cloud Platform. It's the thing where all of your containers go onto. Your containers are your applications or your services or your workloads, and they go on top of the platform. You can see on the left side of the container ship is where the captain is, way up high, monitoring things, making sure everything is going well. That's Kubernetes. It's orchestrating everything to make sure that your containers are safe and running properly. And that container ship is gliding on the ocean, which in this metaphor is the giant and scary internet. So Kubernetes is the thing guiding all of those things on the internet. But this is a slightly more specific and technical diagram of what a Kubernetes cluster looks like. Let's break this down. So there are 3 squares here. There's a master node and 2 worker nodes. The master node on the left runs the services that comprise what we call the Kubernetes control plane. These components on the master are the captain, and the control plane stores all its data in etcd. Control plane also decides on which nodes it's going to schedule workloads and containers, and it communicates with those nodes via the API server. So it's really, that's the thing that's controlling everything. The 2 squares on the right represent 2 worker nodes. Each worker node has a component called the kubelet, which talks to the control plane, as well as the kube proxy, which is the service that exposes your pods to the cluster network. Then you can see on the worker nodes, there are things called pods that are the actual Docker containers, and we'll talk about those in a moment. So why Kubernetes? Why do companies choose to use this system when it is so complex? With Kubernetes, developers can specify the exact design of how they would like their application architecture to be deployed out, including how many resources, CPU, and memory each container should get, how many copies of the container to run, how to expose all these containers as web services and load balance them, how fast we should scale these things, and many other things like DNS management, metric collection, logging collection. So in summary, Kubernetes orchestrates computing, the network, and storage infrastructure on behalf of the user's specified demands, which is a really powerful concept. While we'll be going over some key objects and resources in Kubernetes today, like pods and deployments, keep in mind Kubernetes is really open-ended and it allows for a variety of workflows and resources to be managed. So keep thinking of Kubernetes like the captain of your cluster who acts in accordance with your specified intentions. So Kubernetes was designed with these things at the core of the actual platform: fault tolerance, load balancing, scalability, idempotent resources, and a RESTful API design that allows for CRUD operations on resources. And I'm going to have you discuss this in a couple of minutes, so pay close attention to this slide. So what kinds of problems does Kubernetes try to solve? You can read through the bulleted list there. And all of these things on this bulleted list are really hard to accomplish without an automated framework that acts according to our will. It lets us treat applications and their components as idempotent abstractions that can be shuffled around and replaced at will. So in summary, Kubernetes provides a robust infrastructure to ensure site reliability. It allows for many automated CI/CD workflow patterns, allowing developers to push code and update it multiple times per day. It allows for teams to efficiently use cloud resources due to its scaling nature. Rather than using a static set of instances, you can automatically scale your cluster up and down to get more compute resources when necessary and scale those down and reduce costs when possible. It allows for fault-tolerant and self-healing deployments and services. And due to its distributed nature, you can spread it out across many regions. And finally, Kubernetes can easily scale up into very large deployments on demand. So hearing this list of problems that Kubernetes tries to solve, it's probably no surprise that Kubernetes originally came from Google. For years, Google ran a massive internal cluster management system for containerized applications called Borg. Google ultimately decided to share a lot of the core learnings and principles with Borg with the outside world. And so they eventually created this open source project called Kubernetes and set it out in the world. Kubernetes was built to support microservices, and it has lots of good patterns to help you if you're starting to decouple or decompose a big monolith application. Kubernetes effectively steers your workloads to be distributed within a cluster according to the resource requirements specified. And so because of this, Kubernetes is a tool that both ops and devs can really appreciate, as it allows for both of those teams to focus on their areas of expertise within your system. So big high-level description, and I just want to show you this simplified view of what Kubernetes architecture looks like from the perspective of your containerized application. So your container runs within a resource called a pod, which can contain one or several containers. Pods are scheduled onto nodes, which are servers that are members of the Kubernetes cluster. Those are those worker nodes we saw in that earlier diagram. That little steering wheel up at the top of this diagram represents the Kubernetes control plane we discussed earlier, which are a set of services controlling the cluster. The control plane maintains contact with the kubelets on each node, which run all of the services on that node. And so here in this diagram, the kubelets report back to the control plane regarding the state of the workloads scheduled onto them. So we're going to engage in a discussion. This is a workshop where you get to be really active. You're going to be building your own cluster in a little bit, but I want you to take a minute and just think about this. So just gave you all of this information about Kubernetes. But if somebody asked you, I've heard of Kubernetes, but what is the purpose of Kubernetes? What would you say? And be ready to share that out. So what is the purpose of Kubernetes? And when you're ready to answer that question, please put your answer in the chat. And I might ask you to elaborate a little bit. But what is the purpose of Kubernetes? You're thinking of your answer, and then you're putting that answer in the chat box. Got some good answers coming in. Kyle says, Kubernetes manages containers across a bunch of physical nodes. Absolutely. Vin says, manage applications, clusters, requirements, and how they run overall. Yep, so that sort of encompasses like the control plane and all of the automated things that Kubernetes does. Krishna says, developer doesn't need to worry about performance-related stuff and concentrate on their business needs. Yeah, so it's one thing we help with at Fairwinds, where we would manage your Kubernetes cluster, and then you would build your apps and focus on your business. So Fernando says, orchestrate the deployment of applications via virtual resources. Excellent. Yeah, so those are all good answers. So one thing to keep in mind is that the word Kubernetes is a Greek word that means helmsman or captain, and that Kubernetes is a container orchestrator. So taking your containerized workloads and scheduling them on nodes and scaling things up and down when needed. Excellent. All right, so this is a time that I would answer any questions that are in the Q&A, and I don't see any in the Q&A, but if you have questions as I keep going, continue to ask them there. Mary will look at them, and then I'll answer them as well. And if you haven't already, or if you came in a little bit late, you want to make sure that you have the Google Cloud Platform Console open. It's at cloud.google.com, because after we go through our next section, I'm actually going to lead you all through creating your own cluster and deploying an application on Kubernetes, and so you'll need access to that. And if you have questions about that, the Q&A feature is perfect. All right, let's see. Excellent. So we're still talking about the high-level concepts in Kubernetes, and now I want to dig a little bit deeper into some of the things that we're actually going to see as we create a Kubernetes cluster and deploy an application onto it. And so these are called Kubernetes primitives, and we're going to start with the idea of pods. So like I mentioned before, a pod is a set of one or more containers that act as a singular unit, and they are scheduled together by Kubernetes. In fact, pods share a network connection to the cluster, and they can share a local file system. Pods are the primary building blocks for your containerized applications on Kubernetes. So when you deploy an application onto Kubernetes, if you've started decoupling it, maybe your front end is one pod and your key value store is another pod. They can be arranged into various patterns by other Kubernetes resources like deployments, which we'll talk about in a moment. So pods are idempotent and ephemeral. That's saying, like pods come and go. They are spun up and killed often. And pods are identical as defined by a specification that you create. When you spec out a pod, each pod spawned out of that specification will be identical. And so on the right of this slide, we see a very abbreviated YAML manifest for a pod. And I just want to go through that and show you what it is. So the very first line, it says API, and what that means is we're using version 1 of the Kubernetes API. Second line, kind pod. You're telling Kubernetes the kind of object I want you to create from this manifest is a pod. Next line is metadata, and there we're naming the pod web app. So when you search for pods, if you were to see that one from the command line, it would be called web app. Next is the spec, and in this pod we have just one container. The name of that container is web app, and the image that's going to create the container is stored in the directory my/web app. So that's a pod. It's the smallest, most common unit in Kubernetes. As an SRE who works with Kubernetes, it's the thing that I interact with the most. So talked about pods. Now we're going to move on to labels. And like we just looked at, we specify pods through manifests and then submit those manifests to Kubernetes. And so how do we keep track of all of these objects? The way that we keep track of these objects are through labels. Labels are key value pairs that describe attributes that are helpful for us as people interacting with Kubernetes, but can also be meaningful to the Kubernetes system. Labels are defined in a Kubernetes objects metadata. Kubernetes objects are persistent entities in the Kubernetes system, and they are used to represent the state of your resources. So if you say, I want 2 pods to exist, and I want them to have that label web app, Kubernetes is always going to be scanning your cluster and making sure that that is true in the state of the cluster. So here with the label, if we look again at the right side of the manifest, we have that API version 1 again. The kind of thing that we're creating is a pod. Then we have the ... What that is supposed to be is that you would add the information for the pod there. And then finally, we have an example of what labels look like in YAML. So we have the metadata tag and then labels. And then we have 3 ways that we're giving value to this pod. We're saying the app is called web app, the tier is called front end, and the release is called stable. So you as somebody looking through lots of pods, you could filter through these labels. And also Kubernetes can use these labels to group things together and make changes to them. So that leads us on to label selectors. Like I said, a label selector is a way for Kubernetes to filter objects using labels. In this example, we have something different than we've seen before. So in the YAML on the right, we have the kind of object that we're creating now is a deployment. In the metadata, we have the name of the deployment is called web app. And then in the spec, we see we have replicas. There's going to be 2. So that means there's going to be 2 identical pods that are created. And here are the label selectors. We're saying grab any pods that have the label app Redis and make sure that the state of things applies to those pods. And then we have the template, the spec, and the containers, and that's what these other parts of the YAML would be. All right, the next Kubernetes deployment is, the next Kubernetes primitive is called a deployment. And a deployment is a template. The way I think of deployments is that a deployment is like a blueprint, and pods are like the actual buildings that get built with that deployment. And so here we can see this deployment, which is called web app. And what it does is it finds and manages the pods spawned by it using label selectors, which is set to app Redis. And so let's take a look at this YAML again. We have API version apps v1 beta 2. We're creating a deployment, this template. The deployment is called web app. We're saying we want 2 replicas of this pod. It should apply to all pods that have the label app Redis. And then we have, we're giving a label to this deployment app web app. And then in the spec is where it gets interesting, because we're saying, I want you to create 2 identical pods that have these things about them. The name of the pod should be web app. The image that you're creating the container from is Nginx. We're going to have a container port at 8080, and we're using the HTTP protocol to communicate with it. And the environment variables that need to be loaded into the pod are the Redis host and then the Redis master. And so this is that blueprint. And so Kubernetes is going to look at the deployment and it's going to say, I'm going to create 2 identical pods that have these things true about it. The pod names will be slightly different. It'll be web app dash and then some unique number and letters. And that is what a deployment is, blueprint for pods. So we've talked about pods, we've talked about labels, we've talked about label selectors, and we've talked about deployments. The last Kubernetes primitive that we're going to discuss are services. So a service is another essential resource type in Kubernetes. Services allow access to a group of pods. There are several types of services in Kubernetes. We'll talk about that in a moment. But a service is important because it has a stable IP address and a stable DNS name associated with it. So what a service does is it keeps that nice stable IP address and DNS name, and it receives traffic either internally from the cluster or externally from the internet, and then it routes traffic to those pods. Because pods come and go so quickly, their IP addresses are constantly changing, and so a service is important so you have that stable IP address that gets the traffic and then load balances across pods. The 3 types of services in Kubernetes, the first one is cluster IP. This is the default service type. It means that you can only receive traffic from within the cluster. There's no external IP, host, or port. And this is something that's helpful if you have services that just need to talk to each other within the cluster. The next type of service is a load balancer. The load balancer has to be provided by your cloud provider. And what it does, it receives traffic externally from the internet and then load balances across pods. And then finally, the third type of service is a node port. The IP for a node port service is affiliated with the node that it's on. It also maps to a static port on the node. This one, node port, is often the type of service that you would use for a tutorial because it's fairly easy to set up, but it's not something we recommend using in production. So that was a big, long explanation of some Kubernetes primitives. I'm going to stop the share and see if there are any questions. All right, I don't see any in the Q&A. And so I'm going to ask you a question and have you respond again in the chat. But what is the most commonly used Kubernetes primitive? And once you know, you can just type it in the chat box. So what's the most common Kubernetes primitive? Ooh, I like those answers. Yeah, so I see 2 people said pods, some other people said deployments and labels. And so the thing that I interact with the most as an SRE using Kubernetes is pods. They're like hundreds, sometimes thousands of pods running on a cluster, and that's where your applications and your services and all of your stuff is working, and that's how you can interact with them. But in order to create pods, if you don't want to create just one pod, then you use a deployment to say, hey, I want to create a set of pods. I want there to be 10 replicas of this pod on the cluster. And so deployments are the most common way to create a set of pods. And then labels are a way of giving those pods or deployments or any Kubernetes primitive or object key value pairs that you can search on. So nice, thanks everybody. All right, let's hop back into it. All right, so now that I've done all the talking, we finally get to the fun part, which is you being able to deploy your first Kubernetes cluster with Google Kubernetes Engine. I want to give you a little bit of information about GKE, and then we'll hop right into it. So GKE, again, stands for Google Kubernetes Engine. It's a managed Kubernetes cluster service from Google Cloud. When you use GKE, you don't have to worry about your Kubernetes masters. Google handles that for you. GKE is also nice because it handles the automatic provision of worker nodes and other things in the cluster. So remember this diagram that we showed earlier on about the master node and the worker node? You do not have to worry about master nodes with GKE. It does it for you, and so it's a nice option especially if you're new to Kubernetes. So why choose GKE over Amazon Web Services or Azure? So Google has been running containerized applications for a long time. Because Kubernetes was born out of the Google project board, a huge portion of the Kubernetes code base was written by Google engineers, and they have many engineers on staff whose main job is to issue PRs to the Kubernetes code base. Because Google Kubernetes Engine came out a little bit after being able to do it on AWS, the user interface and the user experience is a lot smoother. And so GKE cleans up a lot of rough edges around authentication and authorization. It's very easy to deploy your first cluster. Cluster upgrades are handled by Google, not by you as the Kubernetes admin. Scaling happens fairly easily, and you get support from Google site reliability engineers who are monitoring when upgrades need to happen. So we're actually going to hop into creating your first cluster. And so what you should be doing now is following along with me. I'm going to go in small chunks, and then I'll stop, ask if people need help. And so the first things we're going to do is we're going to spin up our cluster, and we're going to configure access. And I'm going to exit out of the slide deck. And this is the part where you should follow along with me. So everybody, go ahead and head over to cloud.google.com. And then you'll want to go to the console. And so if you're part of an organization, you can either select a project or create a new project. I'm actually going to create a new project for this, and I'm going to call it GKE 101. And so I'm going to create that project. And sometimes this takes a few minutes to spin up. So go ahead and create your own projects. If you want to see notifications or status, you can go here. Perfect. And then I am dropped into my project dashboard. I'm going to stop sharing. I've got something in the Q&A. Huh. I'll get to that question in just a second. So if you are having trouble accessing the Google Cloud Console, or you're not sure how to set up your project, please drop a question in the Q&A. Vin asks a good question that I'm going to answer now, and he says, what are some examples of how big organizations have used Kubernetes? So the Kubernetes documentation actually has some really good examples of organizations that that use Kubernetes. And so my favorite example is when Pokemon Go first came out, that they built their infrastructure on Kubernetes because they realized they were probably going to get lots of users when they first started, and they would need to be able to scale up and scale down to support all of their users. So that's one example. I believe the New York Times also uses Kubernetes, but Kubernetes is handy for handling those kinds of spike in user requests, as well as being friendly for your developers. So hopefully the Pokemon Go developers, New York Times developers are able to push changes to Kubernetes a lot more quickly than on a more traditional infrastructure built with VMs. So, all right. Okay, Eric, it looks like you're set. All right, let's hop back into the Google Cloud Console. Cool. All right, I'll share my screen. All right, so yes, looks like we're on the right screen. So once you have your project set up, then what you're going to do is you're going to find the GKE dashboard. And the way that you do that is on the far top left, there's a hamburger menu called the navigation menu, and you want to go down to the Kubernetes engine. And again, this says the Kubernetes engine API is spinning up. It may take a minute or more, that's fine. We'll pause for a second. All right, occasionally a refresh in the browser shows us something different. So I'll do that. Nope, looks like it's still spinning up. Oh, there we go. All right. So once the GKE API has been enabled, you're going to click on Create Cluster. And on the left side, there are several cluster templates. What we're going to do is we're going to use the Your First Cluster template, since we're just deploying one application on this cluster. And so this warning here just says some fields can't be changed after the cluster is created. If you have questions, you can hover over the question mark. And so just be thoughtful as you decide these things. Let's see, I see there's some things in the chat, so let me look at those before I go on. Nice, okay. So David says, first time users see a notification that requires billing to be turned on to continue. Thanks for that info, David. So if you're not able to get into the dashboard, make sure that billing is enabled. Cool. All right, so I'm on my first cluster template, and I get to name the cluster. So I'll say GKE 101 1. And then you can decide zonal or regional. Zonal means that all of the computers for your cluster are in one availability zone, whereas regional means it's spread across regions, which is good for high availability. So let's go ahead and go with regional. And then for me, the default region is US Central 1. I'm going to go with that. So the master version, this is where you specify what version of Kubernetes you want. We're going to go with the default, which is 1.13.7. If you needed something else, you could go down to this drop-down menu and select something. Here we have node pools, and that's how many computers you want to be your worker nodes. And we're going to start with 1, and it looks like there are 3 availability zones in this region. So I expect to have 3 computers. If you knew you needed more nodes, you could add more node pools here. We will not do that right now. And then if you were using a service mesh like Istio, you would enable it here. We're not going to do that. So I'm going to hit create. And this, like the other parts, may take a little while to finish working. So my Kubernetes clusters are spinning up. And just a reminder, the thing that we're working on right now is we're spinning up our cluster. And as soon as that's done, we're going to configure access to the clusters. I just saw that my screen is maybe a little too small, so I will bump that up. So my cluster is spinning up. Your cluster should be spinning up. If you haven't gotten to the part where you've specified your cluster and you would like help, drop a question in the chat or in the Q&A, and we will work with you to get that figured out. All right, so still waiting for that cluster to be created. Again, you can look at the notifications here. And occasionally a browser refresh gives you different information than what the Google Cloud platform shows you. So as we're waiting for that to happen, let's again, so we are spinning up the cluster and we're configuring access. As we configure that access, I ask that you use the Google Cloud Shell, not the command line on your computer. Mary and I can help you debug with the Google Cloud Shell, but we can't help you if you're using the command line from your computer. So I'll show you how to use Google Cloud Shell, but it's really important that you use that for this demo. All right, awesome. I have a green check mark, which means my cluster is running. It looks like I've got 3 nodes. And now what I'm going to do to configure access is I'm going to click the connect button. I'm going to copy this command because that's what's going to allow me to be authorized to view and perform actions on my cluster. And then I'm going to run in the Cloud Shell. I'm actually going to pop the Cloud Shell out into a new window. And again, this takes a little while to provision. It says establishing connection to your Google Cloud Shell. Awesome. So I've got just this command line here, and I am going to paste that command that I copied from the prior window. And if you need to see that again, you go to connect and you can copy the command there. And I will increase the magnification here. So mine says Kim at Cloud Shell. Whoops. And so whenever I am working with Kubernetes and I want to make sure I'm connected to the cluster, what I do is I just say, hey, Kubernetes, can I see the nodes that I have access to? And the way that you do that is kube control get nodes. And so when I type kube control get nodes, I see I have 3 nodes here, and they're not very old, but they are ready to go. And so I'm going to pause here. I'm going to let you catch up, and I will know you are ready when you run kube control get nodes and you see a list of nodes for your Kubernetes cluster. If you have questions, ask in the chat or ask in the Q&A. And let's see, it is 10:53 my time. We'll get started again at 10:55 my time. So that's 2 minutes. Your goal is to get connected to your cluster. All right, so it's 10:55 Mountain Time. Let's see, if you need help, ask in the Q&A channel or ask in the chat, and I'll have Mary assist you. So what we did is we created a cluster, and then we configured our access to that cluster by clicking on this connect button and copying this command. Then we use Google Cloud Shell to connect. And then finally, we just want to make sure that we're connected to our Kubernetes cluster by typing kubectl get nodes, and we should see a list of nodes. So if you're not there yet, let us know. We can even hop on a different call with you to get you set up. But let's see, nice. So Mary's giving some instructions about how to get that command. So I'll show it one more time. So I'm on the, let's see, if I went home, I'm in my project, and then I head down to the Kubernetes engine dashboard. And then from there, I've got my cluster running. I click on the right button that says connect. From there, I copy this entire command. And then if I click running Cloud Shell, and now I've got 2 instances of Cloud Shell running. And then you would paste that command. And I've already authenticated, so I don't need to do that. So I'm going to reconnect there. Make sure I'm still able to access Kubernetes. So kube control get nodes. Oops, I spelled nodes wrong. Kube control get nodes. Cool. Looks like I am good to go. All right, so let's take a look at where we are in the workshop. Just a reminder, please use Google Cloud Shell. And so what we did is we just deployed your first Kubernetes cluster using GKE, which is awesome. So there we go. Next up, we're going to deploy a simple web application to your cluster. And so this is the way that the web application is going to work. So we have our cluster running on GKE, Google Container Engine, and we are going to have a web application that has a very simple front end that's also connected to a Redis backend that's going to store key value pairs that we pass in through the URL. And the service that's load balancing across those web app pods is the Google Cloud Load Balancing. And so here, what we're going to do is we're going to deploy Redis, and we're going to deploy a web application. And so I want to show you, this code is already written for you. You don't have to worry about it. And so it is at our Fairwinds GitHub organization. I'll show this at least twice. So if you go to github.com/fairwindsops, you'll see our Fairwinds organization page. So we've got this F in the corner, our logo. And the thing that you want is pinned to the front page of our org. It's called K8's Workshop. And so what you're going to do is you're actually going to clone this onto your machine through the Cloud Shell. So I'll do git clone. All right, since I've practiced this, I already have that, so I'm going to remove that, and let me clear that and show it again. So git clone. And then I'm going to list all my files, and I can see the Kubernetes workshop here. So I will paste that command in the chat, and then I will go over that again. So if you want to skip right to git clone. So if you are starting here, so we go to github.com/fairwindsops. That leads you to our GitHub organization. Then you go to the K8's workshop. Once you're there, you go to this green button which says clone or download. I'm going to clone with HTTPS. You copy that to your clipboard. And then in the Google Cloud Shell, you say git clone, and then you paste that URL and then hit enter. So I'm going to give you a minute to do that. If you are already there, you can change into the K8's workshop, and we are going to be using the complete directory. If you want to start poking around and seeing what's in there, go ahead. Awesome. Glad you're caught up, Laura. Thanks, Mary. So you're cloning the K8's workshop code onto your machine that's running Google Kubernetes Engine through the Cloud Shell. All right, so I'm working under the assumption that you've cloned that repo onto the computer that's running Cloud Shell. And I'm going to clear my terminal real quick. And I'm going to make that bigger. The Cloud Shell, like it defaults back to whatever magnification it does. So forgive me, it'll be up and down. So if you list all of your files with ls, you'll see the K8's workshop. You want to change into that workshop. So cd K8's dash, if you tab, it'll autocomplete for you. And then this is really, really important. You want to then change into the next directory, which is called complete. So you want to be in the complete directory. That means the app is already built for you, and all we have to do is apply the manifest through some Kubernetes commands. So if you want just one simple command, you'll do, yep, Mary just posted, change CD into K8's workshop complete. And then if you want to look around, please do. All right, so let's look back at our slide deck, see where we are. So what you're doing is you're going to deploy Redis and you're going to deploy a web app. And this is going to be a part of the workshop where you're working on your own, reading through the directions, and then letting Mary and I know if you get stuck. So here's how it's going to work. If you go to the README for the complete directory, it will give you all the instructions and all the commands that you need to run. So the first thing you're going to do is you're going to deploy the Redis database. And then the second thing you're going to do is you're going to deploy the web app. So I'll just show you the very first command. So it says create a namespace in Kubernetes. And so if you wanted to, you just copy kubectl apply -f. That means kubectl apply the file that I tell you. So namespace.yaml. And so if I do kubectl apply namespace, says namespace K8's workshop created. Cool. All right. And then you go on and you will run those commands. So all the commands for deploying the backend Redis are perfect. They're all set up. You can just copy and paste them. When you get to deploying the web app, we set this up so you'll intentionally make a mistake first, and then you'll go back and fix it. And so what will happen when you deploy the web app is you will apply it to the default namespace, not the K8's workshop namespace. And you'll find that your front end and your back end can't talk to each other because namespaces are separated. And so on step 3, you fix the broken deployment by adding the namespace, and then you test the deployment. So your job is to go through all of these things on your own, stop before you get to scaling the application based on CPU. but you're deploying your backend and you're deploying your web app, and then you're going to intentionally make a mistake and then fix it so you learn more about namespaces. I'm going to start with 10 minutes on the clock, and I'll check in there. And if you need more time, I'll give it to you. If not, we'll move on. If you have questions, put something in the chat or the Q&A. And before I cut you loose, I'll answer Vin's question. So Vin says, what's the purpose of the Redis server? And so Vin, as you move through the instructions on the README, you'll actually be able to pass data to the Redis server through the URL. So it's going to save key value pairs that you can then look at later through the web app. So it's a toy web app. It doesn't actually do something you want a web app to do, but it's a way of storing data for us. So I'll put 10 minutes on the clock. You're working through the instructions in the README, and you're stopping before scaling the application. And we'll talk about what we've done in 10 minutes. So ready, set, go. All right, we've got about 5 minutes left. And some of you may be done, some of you maybe are just starting. That's totally fine. I'll check in and see if you need more time at the end of 5 minutes. If you are someone who has run through all the instructions in the README, then go ahead and just look in the files in the Redis and then the web app and just look at what those deployments are and find, are they pods, are they deployments, are they services? What are the labels? Are they using label selectors? So start getting curious there. So still got 4.5 minutes. I'll check in at the end there, and then we'll see if we need more time to explore. All right, we've got about 2 minutes left. We've got some awesome questions in the chat and the Q&A box, so keep those coming. I don't think I told you this, but after the 2 minutes is up, if you're ready, I will demonstrate deploying all these things to the cluster. So if you feel really confused or you're not sure where to start, I will show you in just a moment. So I've got 1 minute and 45 seconds. All right, whatever you're working on, go ahead and wrap it up. In about 30 seconds, I'm going to demonstrate deploying the back end and the front end to our Kubernetes cluster. And then I'll show you how to do the load testing at the very end. And then it'll be time to wrap up after that. All right, so what I'm going to do now is I'm going to run through the instructions and debug when I have issues by deploying this web application to my Kubernetes cluster. So it looks like my screen is shared, which is awesome. And I'm actually going to put this in a new browser window. I just have the Cloud Shell and the instructions side by side. All right, and actually want them on different sides of my screen. Almost there. Nope, nope. Okay, there we go. All right. Oh, I'm sorry. There we go. Okay. So from the Cloud Shell terminal, I'm in the K8s Workshop complete subdirectory. And the first thing I'm going to do is deploy the Redis database. And I need to deploy a new namespace for our application, deploy the Redis server, and then review the deployments and pods and use kube control. And so I believe I already created the namespace, and I can make this bigger. And so in Kubernetes, the way that you look at namespaces is you say, kube control get ns for namespaces. And Kubernetes by default will have a default namespace. It will have a kube public and a kube system namespace, which we see. And we also see this namespace that I created. Awesome. Step one. Step two, I want to deploy the Redis master and replica. And it says, I'm going to say kube control apply these files in this directory 01 Redis. So if I look in that directory, I've got lots of YAML files. I have a network policy, I have a primary deployment file, a primary service file, a horizontal pod autoscaler file, and a service file. I just want to apply all of those files all at once. And so the way that I do that is kube control apply dash, and then I just pass in the name of the directory. Excellent. So Kubernetes says, I created that deployment, I created that service, I created the replica deployment, I created the horizontal pod autoscaler, I created the service, and I created the network policy. Outstanding. So what do the instructions here say? It gets the deployment resource from Kubernetes in the default namespace. You will not see the Redis deployment, so we've not deployed them to a different namespace. Okay, so it says, look at your pods, and it says kube control get pods. So kube control get pods. Oh no, it says no resources found because I'm not in the right namespace. And so if I use the up arrow to get that command and I pass in the namespace K8s workshop. Ah, cool. So here are my pods. The name of the pod was Redis primary and Redis replica, and I have one of each. And I have this unique ID at the end of the pod because I might need more than one of those pods in the future. So it has to have that uniqueness added to it. Cool. So I can see the pods. Now it's saying I should look at the deployments and the pods. And so the way I will do that is kube control get deploy, comma, pods. Namespace K8s workshop, and I should be able to, oh yeah, I have an alias on my machine where I just type K for kube control, but that's not true of this machine. Kube control, get deployments, and get pods. So now I can see both of those Kubernetes resources, my deployments, as well as my pods. So I have the Redis primary pod and the Redis replica pod. And then it's saying, why don't you look at the services in the K8s workshop? So kube control, get services, namespace, K8s workshop. All right, so I have the primary and replica services. They're type cluster IPs. These are the IP addresses. There's no external IPs. And then last thing is look at the logs of one of the pods. And so when you use this command where you're looking at a set of objects deploy in pods, it'll tell you the object ahead of it. You don't need that when you're looking at logs. So if I want to look at the logs for my Redis primary pod, I say kube control logs, then I say the name of the pod, and then I tell the namespace K8's workshop. Oh, cool. So since it's a Redis pod, got the Redis console log, and then all of the information from the Redis logs. That's standing. And I use that all the time to debug issues that are happening in pods. So at the end here of these instructions, it says, we should now see a healthy Redis master and replica in the K8's workshop namespace in Kubernetes. So I just showed you how to deploy the backend to your Kubernetes cluster. What questions do you have? Please put them in the chat or the Q&A box. All right, I'm going to go on. If you do have questions about the backend, please still put them there. So now, whoops, hit the wrong button. Now I want to deploy the web app. And so I'm going to head to that. Let's see. There we go. And I'm going to deploy it to the right namespace right away so we have time for some load testing and more questions. So I'm going to clear my terminal. And it says deploying the web app. So initially, you deploy the web app to the default namespace. We want to show you that namespaces are hard boundaries for pods. They can't talk to each other if they're in separate namespaces. Watch the cloud load balancer create external access to the web app, curl the newly deployed web app to test manually, look at the logs, fix the broken web app, and then curl. And so what I'm going to do is I'm going to deploy the web app to the right namespace, and instead of curling, I'm just going to make the request from the browser and show you what the app does. So deploy the basic web app. And so I'm going to say kube control, apply the files in the 02_web app directory, and I want it to be in the namespace K8's workshop. Excellent. So config map was created, deployment, an HB network policy, and 2 secrets. And so if I say kube control get pods from that namespace. So now we see I've got this container creating, and I have a pod for my web app. Excellent. All right, now it says test the web app. So I can't use the IP address from the pod, but I can use the IP address from the service that should be available from the internet. So if I say kube control get services from the namespace Kubernetes workshop. All right, so I'm looking here for the external IP column. The external IP is still pending, so that cloud load balancer must be spinning up. And I'll just run that command until I get it. I wonder if we could see the, I'm not gonna try, well, maybe it says here. Initializing Kubernetes engine, nope. There it is. All right, so it says external IP. So I'm going to grab that IP address. I'm going to open a new tab in my browser. It must still be spinning up. All right, cool. It says, hello from Kubernetes. I am serving from the pod web app with this unique ID at the end. So GX68, let's see. I wonder if that's the pod name. Hey, there it is, web app, and then it ends with GX68. Cool. So I didn't break the deployment. I deployed it right the first time, and now it says test the new deployment. And so the way that this web app works is it just saves key value pairs in Redis that you pass in through the URL. So if I say name/Kim, so it added a key value pair name of Kim. And so if I just go to name, oh, it doesn't know that, but I bet if I take that trailing slash off, so now that's in the Redis database. Cool. All right, so I've tested the new deployment, and that is it. So I'm going to check and see if there are any questions. We're almost there. Let's see. Yeah, Kyle asked a good question. Mary gave a great answers. Kyle's question is, do you run development and staging services on the same cluster as production? And Mary answered correctly. We have separate clusters at Fairwinds for staging, development, and production. Although you can separate those things via namespaces in one clusters. Can apps talk across namespaces? No, they can't. Namespaces are like pretty hard boundaries unless you configure them so that they can talk to one another. But they are used to separate things. And yeah, I think Mary's got it. All right, so the last thing I want to show you is how Kubernetes can scale things up and down based on the amount of user requests that you're getting. And so I'm on this last part, which is called scaling the application based on CPU. And so the first thing I just want to look at is in web app, there is this file called horizontal pod autoscaler. And what this says is, for the web app, I want you to have always at least one version of that pod running, and you can have a maximum of 50 versions of that pod running. And you start scaling when CPU utilization is 30% or above. And so we're actually going to apply some load tests to this web app to see the horizontal pod autoscaler work. My big caveat is sometimes this doesn't work. Sometimes when I do the load test, it kicks me off my personal internet connection at home, so I may drop and come back on, but I'm going to demonstrate it. What I would say for you is don't do this until we're done with the workshop, and then you can see it for yourself. So just watch me for now. So let's go back to the instructions. So the first thing we need to do is we need to download this piece of software. It's called AB. It's Apache Bench Testing. And so the command to do that is this sudo get install Apache 2 utils. So let me go to Cloud Shell and let me run that command. And it just gives me a warning and says, when you close Cloud Shell, that's going to go away. And I say, that's fine. Almost done. Great. And then if I just say which AB, I have that software in my bin. And then I'm going to apply some load. So let me tell you about this command. So AB is to get that software, and then N is the number of requests you're going to send to URL. So we want to send 30,000 requests, which is a lot. And then C stands for concurrency. So how many concurrent requests we're going to make. When I use 100 current requests, it takes down my internet. So I'm going to change that to 30. And then the last thing is you pass in the URL of your service that gets traffic from the internet and passes it to your pods. So let me copy that. And my concurrency is going to be 30, not 100. And then I am going to just grab this URL. And I need the protocol up front. So HTTP. And I'm going to leave the port number off for now. If we need it, we'll add it. So I'm going to start that load testing. Oh, it doesn't like that. Doesn't like my URL, so maybe I do need that. Let's see. I can't tell what I did wrong, so let me just try again. HTTP -30. All right, and the trailing slash. Thank you, Charles. All right, there we go. So now Apache Bench is sending all of those requests to that URL, and it's going to take a little while. It's doing 30 at a time. And so what I want to do is open another tab. And what I'm expecting to see is once CPU utilization reaches 30%, that Kubernetes is going to start creating new pods because there needs to be more instances of the web app accepting traffic. So let's see, if I say kube control get pods from the namespace K8's workshop. So right now I just have one of those pods. And if I go back to this other tab, looks like it's made 3,000 requests so far. Let's go and look and see maybe workloads. Just poke around the cloud platform. Ooh, interesting. So right now, Kubernetes wants to have 4 of those web app pods. It's only got 1, and it's saying does not have minimum availability. And so what I think is happening is that I don't have enough nodes in this cluster of mine. So let's go to clusters, and let's click into that. And I'm going to add a node pool. So there are more computers that can run this web app. So pool 2. Beautiful. I'm just going to save it. So now I'm adding another node pool. And I'm going to go back to the Cloud Shell. So 9,000 out of 30,000 requests have been completed. And if I run that workshop, oh, great. So now I have 1, 2, 3, 4 versions of that pod running. You can see 3 of them just started 76 seconds ago. So Kubernetes is scaling up now that I've given it permission to have the node pool have a greater number of nodes. And I'm curious what it says here under workloads. Ooh, and one more issue. Okay, so there's insufficient CPU and insufficient memory. I'm hoping that gets cleared up by adding that extra node pool. All right, let's take a look in the actual cluster. So now I've got 1, 2, 3, 4, 5, 6 pods. One of them is pending, and I'm betting it can't spin up because there may not be enough resources. So let's look at the logs for that pod. So kube control logs, pod name, namespace, Kubernetes workshop. No, it couldn't be created. So instead of looking at the logs, let's look at the pod specs. Kube control get pod. All right, just says container creating. And let me refresh this again. All right, so it wants 12 pods, but it's only got 5. So I would probably, I did not enable cluster autoscaler. That's something I would want to do, or add more clusters by hand. If you want to do it in the more modern way, cluster autoscaler will do it. So let's see where we're at with the requests. All right, so it looks like all those requests are done. And eventually Kubernetes should start scaling down because we don't need that many pods anymore. So we're still creating containers. Looks like there's a little bit of latency there. So I would recommend you run that load test when we're done with the workshop, just so you can start looking and exploring and seeing how does Kubernetes do that? How do you add a node pool? So let's take a look at this. So I see a Q&A. I'll get there in just a second. All right, so What we just did is I showed you how to test drive your cluster. You're going to do that when you are done and improve upon it. And just the last thing I want to say is make sure you delete your cluster when you're done so you don't get charged for it. So when you're done exploring, probably at the end of this, let's see. What I'm going to do is just delete it right here, delete my cluster. And then if I go to my home menu, I would also like to delete my project. You can see how CPU went up. So you would shut down your project and you have to type that in. All right, so I shut down that project just so I don't get charged for it. All right, so I see that Q&A. So what's the difference between letting clusters auto-scale versus auto-scaling pods? Oh, that's a good question. So there's a feature in Kubernetes called Cluster Autoscaler, which monitors your requests for CPU and memory from pods. And if pods can't be created because there's not enough resources, then Cluster Autoscaler will start adding those nodes instead of what I did, which was manually. So pods will scale as much as they can until they run out of resources. And then if they run out of resources, Cluster Autoscaler takes it over. All right. So if you have more questions, please type them in the Q&A. And let's look at our agenda and see where we are. So again, make sure you delete your cluster when you're done so you aren't charged for it. All right, so what we've done is we've talked about what is Kubernetes from a very high level, as well as from some of the concepts of Kubernetes like pods and deployments. You created your first Kubernetes cluster with Google Cloud Engine. And then you deployed that web app with a Redis backend. And then once we're done, if you want to apply that load test, you can test drive your cluster. And now what I'm going to do is I'm going to hand it over to Drew, who's going to tell you a little bit more about what we offer at Fairwinds. And after that, we can do a Q&A. So there is Drew. I'll mute myself and unmute him.
Great, Kim, thank you so much. And thanks again for everyone for joining. I guess a virtual applause to Kim and Mary for doing an awesome job here. So what I wanted to do was just take a couple quick minutes to tell you a little bit about who Fairwinds is and some of our offerings. And then at the conclusion of this, right, if you'd like to learn more, there's certainly some links for you to submit a request, and we're more than happy to reach out to you. So as Kim had already previously mentioned, what we are is we are a fully managed Kubernetes service provider, and we're set out to take on the undifferentiated work of handling your cloud infrastructure so that you all get to focus on what you do best, which is building really unbelievable applications. We've been doing this for now about 4 years. We've probably built and managed, at this point, hundreds of clusters across dozens and dozens of our customers. And so really what you're getting by engaging with us is really deep expertise who's kind of gone through all sorts of learning along the way so that we can really be the experts and providing our expertise again, so that you have to worry about anything when it comes to your infrastructure. If you want to hit next, please. So when you hear me say, okay, we are a fully managed Kubernetes service provider, you might think, okay, well, isn't GKE already a service, or excuse me, a managed Kubernetes service provider? And yes, you are correct. They are. They're best in class, right, in our opinion. But what we see our customers engage Fairwinds for is that there's a significant difference between just being able to build a cluster and then actually fully maintain it. So I think this graph here does a pretty nice job visually of showing what I mean by that. So if you think about the layer here at the bottom, the GKE layer, excuse me, and everything, all the decisions that go into to then actually running your application, it gets pretty complex, right? There's a number of things that you really need to worry about. So what Fairwinds does is we take on all this heavy lifting using a variety of our open source tooling and best practices, but we take care of things like 24/7 monitoring. So responding to pages at 3 a.m. and taking care of it before you wake up and even know that anything was wrong. We're finding that customers really are engaging us with our expertise around CI/CD patterns. RBAC, right? That has come up in a number of calls, right? Handling role-based access control can be very challenging in Kubernetes. We actually have some open source tooling around that to make it very easy. But even things like handling security patches and different upgrades, right? Again, our job is to stay on top of all of this so that you can focus on handling your applications. You want to hit next, please? And so we have a few different types of offerings, but let me just take a minute to tell you about how we engage with our customers. So all of our engagements begin with what we call a deep dive. And what this is about a 2-week engagement where our engineers meet with your engineers and get a full understanding of what's in place today. And at the conclusion of that 2-week period, what we do is provide you with a report of our recommendations. From there, we would then also give you a project plan for how we would go about implementing those recommendations. So we have offerings that are hands-on keyboard, where we will take care of really everything for you, including helping you with some CI/CD work and containerization patterns, and then supporting you along the way and teaching you how to handle the rest of those. To things that are a little bit less hands-on, but still hugely valuable for customers, and that's our advisory. So the way we engage with our customers is we sit in a shared Slack channel with you all, and throughout business hours, you can reach out to us at any point in time with questions, and we're there to respond to you. We can certainly jump on Zoom calls as well. So that's one thing that I think our customers really appreciate about Fairwinds, and Kim and Mary are good proof of that, hopefully today, is that we really value the human aspect to it. We take a considerable interest in your business, because even though infrastructure, we've got patterns, and the way we can scale as a company is by kind of utilizing our best practices. We do certainly realize that each customer is different. Everyone does have their own needs, and as a result, we can tailor our offerings accordingly. So that's at a very high level. Certainly what we can do is, if there is interest in learning more about our advisory or any of our cluster ops services, what we would typically do is schedule just an introductory call, and we would bring on one of our SRE pod leaders to sit in on one of those calls and talk through some of your technical requirements. And then if there's a fit, we can continue on with the discussion. So would love to find some time to talk with each of you all. So thanks so much.
Great, thank you, Drew. All right, so if you have any questions, I'll make sure that you can unmute yourself and ask them, or you can use the chat or the Q&A. And if you would like to receive a copy of the slide deck and a recording of the workshop, please fill out our Cube survey here. The link is that bit.ly link. Otherwise, that is it. Thank you so much for joining us. This was our first webinar like this, and it was a lot of fun. And yeah, we hope to hear from you soon. And make sure you delete your clusters. All right, Laura, let me figure out how to get you to talk. Okay, Laura, I think we can hear you now. Or if you unmute yourself, we'll be able to hear you. All right, I can hear you, Laura. Oh, thank you, Scott. Scott put the link for the survey in the chat. Laura, you were unmuted, then I muted you again. If you have a question you want to ask out loud, just raise your hand again and we can do that. All right, so please take the survey. That's how you will get the slide deck and the recording of this webinar. If you have questions, I'll hang out for a couple more minutes to answer those. Otherwise, you can reach out to us on Twitter or ask in the survey. And other than that, that is it. Thank you so much. All right, last call for questions. I see Kyle's question. I'll answer that. All right, I'm going to hang on for 1 minute, and then after that minute, I'm going to close the meeting. So last call for questions. All right, thanks y'all. It's great having you. Hopefully we'll talk soon.